Today in the class, we are going to start with the reversible reactions. The reversible reactions are the reactions which take place in the forward direction and which goes in the backward direction also. Now, let me give you, and they're represented by a double-headed arrow. Now, in our syllabus, we will come across two examples of reversible reaction. One is basically Haber process, and in Haber process, we prepare ammonia because of the reversible reaction where the nitrogen and hydrogen react together to give you ammonia gas, right? Let's balance it. So we will be having 3 here and 2 here, and this is a reversible reaction. The second example is the contact process. In contact process, the sulfur dioxide react with oxygen and undergoes a reversible reaction to form sulfur trioxide, right? So this is the second reversible reaction, which is on our syllabus. As I've said in the introduction, that the reversible reactions are the ones which go in the forward direction as in the backward direction and are represented by a double-headed arrow. Now in this, let's see the first scenario where nitrogen and hydrogen combines together to give you ammonia. But as soon as the ammonia forms, a certain concentration of ammonia is formed, then ammonia will be breaking down to give you nitrogen and hydrogen. Similarly, the second example is the contact process where sulfur dioxide and oxygen will combine to give you sulfur trioxide. And the sulfur trioxide concentration जब कुछ amount में sulfur trioxide बन जाएगा तो वो dissociate होना शुरू हो जाएगा, decompose होना शुरू हो जाएगा to give you the reactant back. So these reactions, they go in the forward direction and they go in the backward direction also, right? लेकिन इसका industrially एक डिसएडवांटेज देखा गया इन रिएक्शंस का, क्योंकि हम यहाँ पर हेबर प्रोसेस के थ्रू अमोनिया प्रोड्यूस कर रहे हैं और अमोनिया के बहुत सारे यूजेस हैं. नंबर वन, यूजेस मेकिंग ऑफ द फर्टिलाइजर. ठीक है, तो अप्रोक्सीमेटली 40 फर्टिलाइजर अप्रोक्सीमेटली 75 to 78% अमोनिया जो प्रोड्यूस होती है वो फर्टिलाइजर मैन्युफैक्चरिंग में यूज होती है. सिमिलरली सल्फर ट्राइऑक्साइड which has been manufactured is actually used for making the sulfuric acid. तो ये दोनों बहुत इंपॉर्टेंट प्रोडक्ट्स हैं जिसको हम नहीं चाहते कि रिवर्सिबल रिएक्शन की वजह से ये डिसइंटीग्रेट हो जाए वापस इनटू इट्स रिएक्टेंट. So the industrialists long time back they come up with this particular problem, and there was a chemist who was known as Lee Chatelier. So he worked in this scenario and he tried to make these reversible reaction go irreversible. That means he tried to make these reversible reaction go either in the forward direction or in the backward direction. Okay, he said there are certain factors. There are certain factors. The factors are basically change in temperature, change in concentration, and change in pressure, and that is only in the case of gases. If we change these factors, then the reaction can go irreversible. It can go in the forward direction or it can go in the backward direction. But before we do these factors which can change the reversibility, of reaction, before we go into details, let's talk about one more terminology which is associated with the reversible reaction, and that terminology is dynamic equilibria. Examiner give us 1 mark question, define what is dynamic equilibria. So reversible reactions, they undergo a state of dynamic equilibria. This is a state of reversible reaction. This is a state of reversible reaction where the forward reaction, the speed of forward reaction becomes same as speed of backward reaction. ठीक है, जब आपकी स्पीड ऑफ फॉरवर्ड रिएक्शन सेम हो जाएगी स्पीड ऑफ बैकवर्ड रिएक्शन के, तो बाहर से देखने से ऐसा लगेगा कि किसी भी साइड पे कोई नेट गेन नहीं है. जब इस तरह की कोई प्रोसेस होता है, इस तरह की रिवर्सिबल रिएक्शन में जब इस तरह का एक स्टेट आता है तो हम उस स्टेट को डायनामिक इक्विलिब्रिया कहते हैं. फॉर एग्जाम्पल, इसको नॉर्मल एग्जाम्पल के तौर पर मैं एक्सप्लेन करने की कोशिश करती हूँ, शायद आपको बेहतर तौर पर समझ में आए. कि आपके एस्केलेटर्स होते हैं मॉल्स वगैरह में, जो एक खास स्पीड से ऊपर जा रहे होते हैं या नीचे जा रहे होते हैं। अगर लेट्स सपोज अगर एस्केलेटर ऊपर जा रहा है और उसी स्पीड से अगर आप उसी स्पीड से नीचे मूव करने लगे, तो यू विल रिमेन कांस्टेंट एट वन पर्टिकुलर पोजीशन। इसी तरह से अगर फॉरवर्ड की स्पीड जो है वही बैकवर्ड की स्पीड हो, तो रिएक्शन में कोई नेट गेन किसी भी डायरेक्शन में नहीं होता। जितना अमाउंट ऑफ आपके पास रिएक्टेंट है, उतना ही अमाउंट ऑफ प्रोडक्ट रहता है, क्योंकि रिएक्टेंट जो है, जितना भी अमाउंट ऑफ रिएक्टेंट है, ठीक है, वो कन्वर्ट होके आपको अमाउंट ऑफ प्रोडक्ट देगा। और जैसे ही प्रोडक्ट फॉर्म होगा वो डिसइंटीग्रेट करके रिएक्टेंट देगा, रिएक्टेंट जैसे ही फॉर्म होगा वो प्रोडक्ट देगा। तो एक तरह से आपको किसी भी डायरेक्शन में कोई भी देयर विल बी नो नेट गेन इन एनी डायरेक्शन, इन एनी डायरेक्शन। ना तो फॉरवर्ड डायरेक्शन में कोई गेन नजर आएगा आपको बज़ाहिरी तौर पे, ना आपको बैकवर्ड डायरेक्शन में कोई गेन। So this particular state where the speed of the forward and the backward is same, we call such state as dynamic equilibria. We call it dynamic equilibria. Now this dynamic equilibria is actually attained as, this is normally attained at a specific, एक खास स्पेसिफिक टेम्परेचर पे अटेन होती है, एक खास स्पेसिफिक कॉन्सेंट्रेशन पे अटेन होती है, एक खास स्पेसिफिक प्रेशर अगर गैसेस हैं। तो दिस पर्टिकुलर डायनेमिक इक्विलिब्रिया इज अटेन्ड एट स्पेसिफिक टेम्परेचर, कॉन्सेंट्रेशन और प्रेशर, राइट। तो अब इन्होंने कहा कि अगर हम यहाँ पर डायनेमिक इक्विलिब्रिया जिस स्टेट पे हो रही है, जिस टेम्परेचर, कॉन्सेंट्रेशन और प्रेशर पे हो रही है, अगर उन पर्टिकुलर उस टेम्परेचर को या उस कॉन्सेंट्रेशन को या उस प्रेशर को अगर हम डिस्टर्ब करते हैं, तो हमारा रिएक्शन या तो फॉरवर्ड जाएगा, ठीक है, या हमारा रिएक्शन बैकवर्ड जाएगा। सो ही वाज अ केमिस्ट हु वाज नोन एज ली शैटलियर। उन्होंने फैक्टर्स एक्सप्लेन करे कि जिस पे डायनेमिक इक्विलिब्रिया, जिस कॉन्सेंट्रेशन, जिस प्रेशर, जिस टेम्परेचर पे डायनेमिक इक्विलिब्रिया अटेन कर रहा है रिवर्सिबल रिएक्शन, अगर हम उनको डिस्टर्ब कर देते हैं, ठीक है, तो वो या तो रिएक्शन फॉरवर्ड जाएगा या बैकवर्ड चला जाएगा। तो लेट्स स्टडी हाउ दीज फैक्टर्स चेंजेस द रिवर्सिबिलिटी ऑफ द रिएक्शन. So let's talk about the first factor in detail, that is the effect of concentration on the reversibility of the reaction. I said there are three factors: concentration, temperature, and pressure. So we are doing the first factor, that's a concentration. अगर हम reactant या product की concentration को ऊपर नीचे करते हैं, increase या decrease करते हैं, तो वो reaction को forward लेके जाएगा या backward लेके जाएगा. Let's look at it, okay? So changing the concentration, if we change the concentration, here are four different options which are mentioned over here. If we change the concentration of a reactant, or let's see, let's go step by step. If we add a reactant, on adding a reactant, any reactant can be A or it can be B. Adding a reactant causes a shift to the right as the forward rate increases, ठीक है। तो अगर आप A या B में से किसी भी कॉन्सेंट्रेशन इंक्रीज कर रहे हैं, तो ऑटोमेटिकली आपके यहाँ पर जो रिएक्टेंट्स हैं वो इंक्रीज हो रहा है, दैट विल लीड टू द फॉरवर्ड रेट इंक्रीज। ये फॉरवर्ड का रेट जो है वो इंक्रीज करेगा, एंड हेंस द रिएक्टेंट फॉर्म द प्रोडक्ट। तो आपका रिएक्शन जो है इंस्टेड ऑफ रिवर्सिबल, बिकॉज इसकी कॉन्सेंट्रेशन बढ़ रही है ए एंड बी का, तो आपका रिएक्शन जो है वो रिवर्सिबल होके फॉरवर्ड डायरेक्शन में जाने लगेगा, ठीक है। अब इसका रिवर्स, इफ यू रिमूव द रिएक्टेंट, ठीक है, अगर आप इसको के अंदर रिएक्टेंट्स को यहाँ पर लेस कर रहे हैं, इनकी कॉन्सेंट्रेशन को अगर आप लोअर डाउन कर रहे हैं, तो डेफिनेटली इनकी कॉन्सेंट्रेशन कंपैरेटिवली इज गोइंग टू बी हाई। जब इनकी कॉन्सेंट्रेशन हाई होगी, तो आपकी स्पीड ऑफ रिएक्शन ऑफ द बैकवर्ड इज गोइंग टू बी मोर, एंड द फॉरवर्ड रिएक्शन विल बी स्लो. And because of that, the equilibrium will be shifted towards the reactant side. That means it will go in the reverse direction, it will go in the backward direction. Now coming the third scenario, what happens if we add the product, if we add the concentration of C and D, if their concentration increases, then again, if their concentration increases, the backward direction speed will increase. So the reaction is going to go in the reverse direction, it will go in the backward direction. Product causes a shift towards the reactant as the reverse reactions rate increases, right? Now reverse of that, if we remove the C and D, that means we lower down their higher concentration, and automatically the concentration of the A and B is higher. Then because the concentration is higher, so the forward reaction speed is going to be higher, and hence the reaction will go in the forward direction, making more of products. Okay, so this was a factor. This is how we can make the reaction go either forward or backward. We can shift, we can disturb the dynamic equilibrium status where the forward and backward are going at the same speed just by changing the concentration. So this is the gist which you should be remembering, right? So if we increase A, the reaction is going to go forward, right? If we decrease the concentration or we remove B, then the reaction is going to go backward. If we decrease C, then the reaction is going to go forward. And if we increase the D, the reaction is going to go backward. So this is how we need to remember how the concentration affects the reversibility of a reaction. Just let me take one example. Now, the example is that how the concentration changes the reversibility. In the case of bismuth chloride, which reacts with water to produce a white precipitate of bismuth oxychloride and hydrochloric acid. So this is BiCl3, bismuth chloride, reacting with water. It's a reversible reaction forming bismuth oxychloride and forming hydrochloric acid. What will happen if you'll add water? If I'm going to increase the concentration of water, what will happen? Definitely the forward reaction speed isn't going to increase because I'm adding one more reactant to it. Now, because the forward reaction speed will increase, hence the reaction is going to go in the forward direction. Okay, now let's see further. What else do we have? See, it's given the equilibrium will shift to decrease the amount of water. That means to the right side. So it is going to go in the forward direction. Let's see the next one. And more BiOCl and HCl will be produced. That means forward reaction is going to take place. Now, if H2O is removed, then what will happen? If you're going to remove this, if we decrease the concentration of water, then what will happen? Then definitely the BiCl3 and H2O will be produced more, because then the reaction, because concentration remove हो रही है, तो reaction जो है वो backward जाएगा. ठीक है? So this is the factor of concentration. Let's move on to the next factor. The second factor is the effect of pressure on the reversibility of the reaction. So what is the effect of pressure? And the pressure is only going to affect the reaction where the gases are involved. Now, the reaction with the gases are not involved, there the effect of pressure is zero. Now, if we increase the pressure, favors the side with the reduced volume. This is a fact. This you have to give in the kind of explanation whenever they'll ask you. And decrease in the pressure will favor the side with the increased volume. Let's see what does it actually mean. Now, change pressure and equilibrium. Changing the pressure has an effect on the equilibria of the reversible involving gases. Equilibria shifts to decrease the pressure. Equilibria will be shifting in the direction of the fewest molecule, as the previous statement has said. Now, let's see how to apply this particular concept. Now, if I have this particular reaction, the reaction of nitrogen and hydrogen combining to give you ammonia. Now, what is happening? We know that in this particular reaction, we have all the gases. We have the gases here, all the gases involved. Nitrogen is a gas, hydrogen is gas, and ammonia is a gas. Then definitely the factor or the pressure will be, if pressure is applied, it is definitely going to make the reaction go irreversible. Now, how? Agar, for example, if I apply the if I increase the pressure, agar main increase karti hu, if I increase the pressure, as we have learned in the previous slide, it is going to favor the side, with reduced volume, right? Reduced volume. That means volume, what do you mean by volume? Means total net number of moles. So we have 1 plus 3, that means 4 moles here, and we have 2 moles here, right? So agar main pressure increase karti hu, it will favor the side with the reduced. If I increase the pressure, then that means which is a reduced volume? The 2 volume out of 2, 4 and 2 volume is reduced volume. So increase in pressure will make my reaction go in forward direction. ठीक है? और अगर मैं decrease करती हूँ, decrease in pressure will favor the side with increased volume. So if I'm going to decrease the pressure, then on decreasing the pressure, it is going to favor the side with increased volume. That means it is going to go in the backward direction, right? So this is what how the pressure is applied. But pressure in this case, what we will be doing will be just counting the moles of the gases, and that will make the total volume here. So I have one volume of nitrogen and three volumes of hydrogen, so that makes four volume of 4 moles. I have two moles, so that will going to make two volume. So जब हम increase करते हैं pressure, तो it's going to favor the reduced volume, and when we decrease the pressure, it's going to be reverse. But what if we have the same number of volume on both the side? I have two volume of gas on the reactant side and the two volume of gas on the product side. Then there is no effect on of pressure. Okay? Then there is no effect of pressure. आप चाहे वहां पे increase करें pressure या आप decrease करें. अगर आपके पास if you have the same volume on the reactant side and the product side, then there is no effect. The reaction is not going to go irreversible, right? There will be no effect of pressure. Here comes the third factor which affect the reversibility, and that's the temperature, right? So in this, we will be looking at the delta H value. Delta H value, if it is positive, we call it as endothermic reaction. And if the delta H value is negative, we call it as exothermic reaction. So the temperature effect will, for the effect of temperature, will be looking whether the reaction is exothermic or the reaction is endothermic, okay? Let's go further. Let's see what else do. Now it says that all the reactions are exothermic or they are kind of endothermic. If the reaction is exothermic, where the heat is given out, or they are endothermic if the heat is taken in. If we increase the temperature, if the temperature is increased, then they are going to favor the side which is basically endothermic. That means which has a positive. Now, if we have a reversible reaction, okay, A plus B is going to give me C plus D, and the delta H value is positive. That means my forward reaction is basically endo, and my backward reaction is going to be my exo. My backward reaction is going to be my exo. So if I increase the temperature, if I'm going to increase the temperature, then it is going to shift, equilibrium will be shifting to the side which is endothermic. So if I'm increasing temperature, so in this scenario, the forward reaction is an endo because delta H value is positive. So the forward reaction is an endo. So if I increase the temperature, it's going to favor in the forward direction. Now, for example, if I decrease the temperature, now decrease in temperature always favor the side which is an exo. So in this scenario, if the delta H value is positive, that means the forward reaction is endo and the backward reaction is exo. So if I'm going to decrease the temperature, then exothermic side will be favored. So that means my backward reaction is going to be favored. So that is a concept behind whether the reaction is going to go forward or backward. That depends on whether the forward reaction is exo or endo. If I increase the temperature, then the endothermic side is favored. If I decrease the temperature, then the exothermic side is favored.